Hello and welcome back to our channel. Today we'll be working on question 3 from the 2011 MAT. The MAT is used by Oxford, Imperial and Warwick for maths, computer science and joint degrees if you're going for Oxford. Let's get started. The graphs of y equals x cubed minus x and y equals m of x minus a are drawn on the axes below. Here, m is greater than 0 and a is less than or equal to -1. The line y equals m of x minus a meets the x-axis at a equals a0, touches the cubic y equals x cubed minus x at b, and intersects again with the cubic at c. The x-coordinates of b and c are respectively b and c. Part 1. Use the fact that the line and the cubic touch when x equals b to show that m equals 3b squared minus 1. This part is worth 2 marks. Part 2. Show further that a equals 2b cubed over 3b squared minus 1. This part is worth 3 marks. Part 3, also worth 3 marks. If a equals -10 to the 6, what is the approximate value of b? Part 4, worth 2 marks. Using the fact that x cubed minus x minus m of x minus a equals x minus b squared multiplied by x minus c, which you need not prove, show that c equals -2b. Part 5, worth 5 marks. R is the finite region bounded above by the line y equals m of x minus a, and bounded below by the cubic y equals x cubed minus x. For what value of a is the area of R largest? Show that the largest possible area of R is 27/4. Pause the video to have a go at the question, and once you're ready, restart to see if you're right. Part 1. Firstly, we have y equals x cubed minus x, and therefore the derivative y prime equals 3x squared minus 1. If x equals b, then the gradients agree, and m equals y prime equals 3b squared minus 1. That's because the line is tangent to the curve at the point, and therefore their gradients must be equal. Part 2. Firstly, at x equals b, we have y equals b cubed minus b equals m of b minus a. Substituting in the value of m we found from the last part, we have the right-hand side is equal to 3b squared minus 1 multiplied by b minus a. Rearranging for a gives us a equals b minus b cubed minus b over 3b squared minus 1, which simplifies to 2b cubed over 3b squared minus 1. Part 3. If a is large and negative, then y equals m of x minus a will be almost horizontal, meaning it will be tangent very, very close to the cubic's local maximum, x equals -√3/3. Therefore, b is roughly equal to -√3/3. Part 4. We have x cubed minus x equals m of x minus a. This rearranges to x cubed minus x minus m of x minus a equals x minus b all squared multiplied by x minus c from the given identity above, which equals 0. Comparing coefficients, we can see that the coefficient of x squared is -2b minus c. So -2b minus c equals 0, and c equals -2b. Part 5. We can see that R is largest when a equals -1, because that would make the gradient really large, and therefore make c really far away. Under these conditions, we have b equals -1 and c equals 2. The area R is therefore equal to the area below the x-axis, which is represented by the first red integral, plus 9, the area of the trapezium, minus the second red integral, which is the area to the left but above the x-axis, and minus the second blue integral, which is the area between the intersection and all the way to c. Now, as this function is odd, seeing as all powers of x are odd, the red sections can cancel out because an odd function is rotationally symmetrical about the origin. We therefore have r equals 36/4 minus the integral between 2 and 1 of x cubed minus x with respect to x. I've written 9 as 36 over 4 because that will come in handy shortly. From the question, we are told that the maximum possible value of r is 27 minus 4, so we only need to prove that the integral is actually equal to 9 over 4. This can be done best by simply evaluating the integral straight up. Evaluating the integral gives us the definite integral 1/4 x to the 4 minus 2/4 of x squared between 2 and 1. This is equal to 16 over 4 minus 8 over 4 minus open bracket 1 over 4 minus 2 over 4 close bracket, which is indeed equal to 9 over 4. And that is the entire question done. If you liked our video, please like and subscribe, and we'll see you next time.